Mathematical modeling. It takes an effort to get through one of these problems, but if you do it step by step, it's not difficult, it's just time consuming. The main thing is to lay out the variables. Now sometimes they'll use the words like y varies with x, or y is a function of x. The last part of the sentence is the x term. So in this one, they said that your electric bill varies linearly with the number of kilowatts you use. And down here they say, write the equation expressing cost in terms of usage. So cost is going to be the y, and the usage, the kilowatt hours, are going to be the x. And we're going to assign some variables. Y is going to be equal to C, and X is going to be equal to K. And we're going to transform this later. Step one is to get an equation. I like it to be in y equals mx plus b format. And step one is going to be, we need to find some slope. So you're going to use the two things they gave you. They gave you the $111 and the $63. Those are our y's. And then they also gave you the 180 and the 100. So we're going to make two little ordered pairs. Now remember, x is the kilowatt hours. So I'm going to write 100 kilowatt hours goes with $63. And 180, don't be tempted to write that 111 first, goes with 111. So let's find the slope, all right? That's step one. So we're going to do a little 111 minus 63 over 180 minus 100. And we're going to get 48 over 80. We want to reduce this. This is a disaster. 8 goes into both of these, so we could make this into 6 over 10. And we'd want to further reduce that to 3/5. It's going to make for a much easier slope. So now let's plug it into our equation. I'm going to choose the 100 and the 63 because 100 is an easy number to work with. Y minus 63 is going to equal 3/5 times x minus 100. And conveniently, this 3/5 will cancel with the 100, so we're going to have a great time converting this. So we're going to say y minus 63, and I'm going to worry about distributing this business. So I've got 3/5 x, and now I'm going to distribute that. So my 5 and my 100 are going to cancel to make a 20. 3 times negative 20 is minus 60. And when I add that 63 to the other side, this is going to be so easy. We've got y equals 3/5 x plus 3. I'm going to change the x and the y now into the variables I need that will remind me what everybody stands for. So the equation that I'm going to really use, and we'll change to green so it stands out. Y is the cost, so I'm going to write cost equals 3/5. X is the kilowatt hour, so I'm going to use K, plus 3. And this is the equation I'm going to use. So in step B, when they say, what is the price of 345 kilowatt hours? With this equation, we can answer any question about kilowatts. We can answer any question about what your bill is going to be by just plugging it in for the appropriate variable. So the price of 345 kilowatt hours, let's plug in 345 into K. So we're going to say C equals 3/5 of 345. Oh, convenient that that's going to cancel. Plus 3. We'll just clean up this mess and everything's going to be great. 5 goes into 345 69 times. And we're going to get that 3 times 69 is 207 plus 3. Yay, the cost is $210. If we want to do it backwards, if your bill was $756, what's your usage? You used a lot of electricity is what you did. But we're going to plug in the $756 into our cost part of it. So I'm going to bring this equation down with us so we don't lose it along the way, and we can know what to plug in. Yeah, so let's plug it into C. So we put 756 equals 3/5 K plus 3. It's not going to be as nice of a problem, but we can handle it. We're going to isolate K. So we're going to get rid of this 3 so that we end up with 753 equals 3/5 K. Now we could do this in 2 steps, but why would I do that when I can do it in 1? So to get rid of this 3/5, if we multiplied by its reciprocal, by 5/3, we could, there's the bell, cancel this out. So we're going to multiply this side by 5/3, and conveniently 3 goes into 753. It goes in 251 times, and when we multiply that all the way out, we get that K, the kilowatts, was 1255 kilowatt hours. That's huge. What is the meaning of the cost intercept? Here's the cost. Here are the kilowatts down here. We know that it's 3. Well, it means that even if you have 0 kilowatts, you are still being charged $3. That might just be that they charge you the $3 just so that you can stay hooked up to the grid. Could be just for billing services. Who knows? But $3 isn't too much. We know that in real life it would be way more than that. And then the last thing is, what are the units of the slope and what is the real world meaning? Well, slope is y over x. And we want to put C, that's our cost, over our kilowatt hours. So what we're really doing is dollars per kilowatt hour. That's what it means. I'll be back with the donut problem later. But let's hope that this helps you out with mathematical modeling.